So for everybody that wants to follow along, I'll put this in the chat. Those are the slides, all the links, or that's actually a GitHub page that serves to my personal website. Actually, my personal website's a GitHub page, but for what that's worth. So this is kind of like a serverless 101 and intro to the serverless framework. And my background is primarily in AWS. So I don't know how much you guys are familiar with that stuff, but that's kind of the goal of the talk that I've got here. So the first half will be kind of like an introduction to Lambda, so that you guys, because I didn't know like what's the base layer that everybody has, right? So introduction to Lambda, and then we'll kind of go from there into talking about the serverless framework and the ins and outs of it, and how you can quickly get like a full-fledged microservice up and running relatively simply, using the framework, and have something that's in production in a matter of minutes that is relatively inexpensive. And we'll actually see some of the stuff work today out of my personal account. If you want to see the code that I'm using as the example, it's in this GitHub repository. Let's start off. So who am I? If you want to contact me, I'm Tompkins@apache.org. I'm a software developer. I primarily do DevOps these days. I've done a bunch of Java. I've done a bunch of Python. I've worked in TypeScript, worked in Golang. These days I'm doing a whole lot of, I'm actually doing a lot of serverless work. So that's why the talk is on serverless. I'm the chief DevOps engineer at patch.com. So patch.com is it's this local news agency, and we in large cities where the newspaper for the city kind of breaks at a national level, there are opportunities for a website like us to have editors at the neighborhood level. And so we kind of have a website where if you signed up in New York and you live in the Bronx, we have a editor that has the Bronx news for you, and you can learn about the school board and things like that. So it's hyper local news, which is kind of fun. And I'm deep in the back end of how that website runs. I've done a bunch of work with Apache Commons. I'm a committer on that project, and one of the committee members for that project. And I'm an Apache member and the Jakarta EE relations manager. So right now I'm currently trying to manage the relationship between the Apache Software Foundation and the Eclipse Foundation, which is kind of an interesting ball of wax. And my background in school is mathematics. I don't know if anybody wants to wax math. I enjoy doing that for funsies. Okay, so has anyone here not heard of serverless computing? Anyone? Raise your hand. Everyone's heard of serverless computing. Okay. So has anyone heard of Google, or like Google Cloud Functions or AWS Lambda? Those are these service offerings that these cloud providers have, where you can essentially execute code, just like a small snippet of code in whatever language you want, right? So, if I wanted to, in AWS Lambda, for example, if I wanted to have like a calculator, calculate 3 plus 5, I could stand this thing up and be like, okay, I just want to do 3 plus 5. So calculator. right? And if I wanted to do calculate 3 plus 5 in Node, well, let's not do Node. I like Python more. Please don't do it in Node. Oh, it's doing it in Node. Well, let's do it in Node anyway. Think. And I could do 3 plus 5, right? Deploy that. I can test that. And if I test that, I should get an execution result that says, no, syntax error, unexpected token. Lovely. That's what I get for trying to do things on the fly. Anyway, if I were to do this in Python, it would have worked better for me, but I clicked on Node. But you get the idea. I can quickly get out here and I can run snippets of code. Okay, so what does that afford us, right? That's kind of an interesting thing. So I don't have any infrastructure to manage. I only have configuration to manage, and I can in Python run things like this where I've got just a function, right, that runs, and I presume you guys have seen some of this stuff, but this essentially is this function here. Where's my hello world API, right? And so I can execute that and send an event in, right? And this will execute the code that we see here. So what is this going to do? It's going to take whatever event I send in, and it's going to take the event body element and put that into the body of a response and then return that. So if I do this, and I make sure one of these is body, right? I get value 1 back out, and it's executed that, right? And so it's this interesting thing, and this thing runs on AWS's infrastructure, which is great. So now I can, at fairly low cost, without much overhead, use AWS's infrastructure. And okay, so you're starting to ask, okay, well, great. This is this event-driven thing, right? How does this help me? Okay, so in the software engineering world, we're more familiar with APIs and things of that nature, right? And so how can I get this function shimmed up into something that actually delivers me value at a business level, right? And so AWS offers another service here called API Gateway that we can shim into this guy and turn this whole thing into an HTTP call, which is really convenient. So, what are we? Pardon, I'm getting ahead of myself. So, what sort of things are afforded us here in the runtime? What sort of bells and whistles are we offered? We've got different permissions. We can actuate different AWS services. They give us environment variables, which is nice. We have, where's the monitoring operations, general configuration? Does that, we've got memory. So that gives the amount of memory that we allocate to the function. We can bump that sucker all the way up to, I think, we can get it up to 10 gigs now. And the actual timeout now on Lambda, it used to be 5 minutes, now it's 15 minutes. That's still pretty limiting, right? But we can have a function run for 15 minutes and be churning away doing computation, which is kind of cool. And we've got a bunch of different other things in here. We've got code signing and all sorts of stuff, right? We can even attach a file system to this sucker. So this is the default sort of stuff that you get. So you automatically get 128 megabytes of allocated memory. You automatically get a provisioned CPU and network. One of the curiosities about the network plane that you get with AWS Lambda is that you're only allowed to run Lambda in a subnet with a NAT gateway. So the networking only allows for egress to the public internet. You're not allowed to run Lambdas in a network space that accommodates for ingress. So that's a security thing that AWS has set up, which is kind of nice and also kind of not nice at the same time. And another interesting curiosity that I've run into in that space is that I wanted to NAT my outbound network through a device as opposed to the AWS default NAT gateway. And I was unable to run Lambda in those subnets. So if you've got like a outbound proxy or something like that at your institution, you can't force Lambda to run in a space with a proxy. You have to accommodate for outbound directly to the public internet, for what that's worth. They may have changed that in the last year, but up until a year ago, I found that to be the case. So there's some interesting nuances, but they accommodate for a variety of different languages, which is kind of cool. And you only pay for code executions. This is one of the remarkable things about these serverless things is that, like, at my current place of work, we run upwards of I don't know, do I have that written down? Here we go. So we have 500 to 1,000 executions per minute of Lambda, and that's $15 a month, which is just remarkable. Okay, so we're taking huge, reasonably large production payloads at extraordinarily inexpensive prices. All the Lambda executions that I've done personally, like I've got an Alexa function or an Alexa app that's out there that runs, that people use, and I haven't paid for it. It's just out there running. So it's remarkable how inexpensive AWS Lambda actually is. And so the next question is, okay, now that we've got this interesting event-driven thing, because when we were over here, we're essentially triggering these events, right? We're triggering, I'm actually having to do something here to trigger this. What are the different ways we can actually get this thing to start? And so there are all these different events that we can listen for, so to speak. There's the SQS queue. There's the SNS messaging. There are all these different events that we can listen to. And one of the most conventional things that we see out there is the need to make an HTTP call. So the question becomes, okay, well, how do I make an HTTP call into a Lambda, right? And so let's look at how we do that. So if you take the API gateway and Lambda and tie them together, you get an event that comes across that looks a little different, particularly if you use this AWS Lambda Proxy. Let me go over to the API gateway and show you what I'm talking about when I say Lambda Proxy. So I don't know how familiar you guys are with the Amazon API gateway. It's fairly complex that accommodates you building up resources at the URI level, and you can declare what your paths are, and it does validation for you and all sorts of things like that. This is a pretty bare bones API in the sense that we just have a root request and it proxies the payload directly into the Lambda. And the integration type is this use Lambda proxy integration, which actually delivers us a payload that gives us the headers and all sorts of different good stuff that we, let me see, does the code log this in this? Let me see, does this log it? Yeah, so this logs that. So we can actually see what gets logged when we run this guy. So let's give this guy a run. So we have the API gateway shimmed into it. And let me go over there and look at that. It's a post, right? So I'm going to actually make a call to this. The URI that we get is this this link. And I've actually got this written down. You can see in the slides here. So this is a picture of what I'm actually going through for folks that wanted to just have like a relatively complete set of slides. But I like actually walking through it as opposed to, you know, going through the slides. So this is what our API call is going to look like. Okay. But let's actually watch that happen. So get that payload. And I'm going to do this verbose so you guys see all the ins and outs of what happens on this HTTP request. Okay, so I get a response of the same thing as the request. And I get all these headers that come back, including this X hello world James Brown, which I think is on the, which is in the code, right? So I put that header in there. And if we wanted to see what the payload coming in looked like, we can look at the log here, and this thing actually dumps that out for us. So I got an event with body value one. Oh, this is the last one. Let's see, the most recent one is 1836. Yeah, that one. That one's better. So this is actually what comes across from the API gateway. The event looks like this, where we get a resource path, HTTP method, and we get a bunch of valuable information back from the API gateway. Do I actually, I get X forwarded 4, so I actually get the IP address of my machine. I'm pretty sure that's my IP address, right? Yeah, 7192. Let me go back over. I got to move. I got the black bar here that I've got in my way. Got to move that guy out of the way. 71, 167. Yeah, so that's my IP address. I get all the headers that I could. So if I wanted to send an extra header across, I'd probably see that show up in here. I get the body of the payload coming across. Okay. And so when we're over there in the Lambda, we can get the event and grab the body out and put that back in the body. And so I'm essentially returning the same thing that I'm sending in, right? My post is set to return the payload that I send in. I could probably send an empty payload and I'll get an empty payload, right? And you guys are welcome to play around with this thing if you want. Please don't drive a ton of load at me. Cost me money, right? But I get an empty payload.
Can I write a Lambda to invoke your Lambda?
You're going to write a Lambda to invoke my Lambda?
We'll make a lot of money for Amazon that way.
Yeah, exactly. Exactly. Okay, so this is all fine and dandy, but this is a whole lot of clicking a bunch of stuff together, and particularly with API Gateway, this stuff is really complex. I mean, there's a lot of stuff in here going on, and I don't know about you guys, but when I get into API Gateway, I've spent a lot of time being lost in the Amazon API Gateway, and I'm like, oh, this is really, really more than I wanted to get myself into, right? And so, I've got some. Let me go about before I get into the serverless framework and what that affords us. Let's talk about the benefits of serverless computing and what we've seen thus far. I'm going to do the benefits and drawbacks here. So, it's really inexpensive. We talked about that early on, that like I've got an Alexa app that I've got running that's super inexpensive. I haven't had to pay for it. My Amazon bill, I think, is like $1.87 a month or something like that, something ridiculous. And that's also the hosting for my website, robtompkins.com. So like, I don't know. You can do things really, really, really inexpensively with AWS if you are careful. You can also do things really expensively with AWS as well. So that's the caveat there. You got to be really careful. It's quickly deployable. I can get this stuff out and running, in a matter of moments. I can have something calling a database, serving an HTTP payload, pretty quickly. I can get that up and running. I don't have to worry about servers. I don't have to worry about maintenance. All that stuff's taken care of for me. So I can get things up and out to production way faster this way. And that's really convenient. There's no infrastructure. We kind of gone over that. There's quick integration with other AWS services. And you've seen some of the integration already with Cloudwatch, right? Because I'm over here looking at the logs of what's coming out of this guy. There's also quick integration with Cloudwatch in the sense that I can go over and look at the metrics of my invocations, like what's going on in terms of duration. I can set alarms on things pretty quickly and easily. So that's all just baked in for you. And so that's super nice. And this is just the AWS perspective on this, by the way. This doesn't, Google has an analogous set of tools with their cloud functions, just for what that's worth. But I'm more familiar with AWS, so that's why we're going through the AWS one. But it's all super quick and easy to tie things together. Now, that's all fine. So what are the drawbacks? Okay. We've already gone over the fact that there's a 15-minute call timeout. So if I wanted to, with a Lambda function, try to do batch processing, things kind of fall apart, right? I can't have something land in a queue and sit there and churn on it for a while and, have it actually do heavy work. So that's kind of a drawback and a bummer. I have done long running Lambdas where I've got like a timer in the Lambda and I pass the payload back into it with some state and stuff like that. But that's a contrivance and probably isn't worth doing. So there's this whole problem of, I don't know if you guys are familiar with this, but the first time a Lambda gets invoked, there's a 500 millisecond overhead, because under the hood, what happens is they start up a Docker container for you and load your code into it, and then keep that running for a certain duration of time that you're not privy to. And after that duration of time expires, you have to do another cold start. So as long as I'm frequently invoking my Lambda, I don't have to deal with this cold start problem. But if I have one call hit it every 30 minutes, I'm always going to have a 500 millisecond overhead, which is annoying. So because of the Docker container in which the code runs and the way the code gets actuated, there's some really strange things that happen. For example, if in Python you were to set a global variable and assign something to it, you can actually persist or cache that information across Lambda invocations. So there's some weirdness that happens under the hood there with the state of what's going on in the application because of the cold start paradigm and the keeping it warm, for what that's worth. So you have to kind of be aware of that and be careful with that. And the next problem is that there are only 1,000 concurrent requests to a Lambda that you can have. So it's not like you can take tons and tons and tons of volume. So that's another issue, where if you're going to write something that's going to take tons of volume, you're going to have to build out some infrastructure that's going to, stand and withstand that volume. So Lambda is a great place for getting ideas off the ground, but once things are really heavily taking traffic, you might want to start thinking about, okay, well, let's put this into a Kubernetes cluster, or let's run this on some VMs or what have you. And because of the way Lambda runs and that each request gets its own Lambda invocation, you can run into some interesting thread pool exhaustion problems. Like if you had a thread pool on a database, right? Like a SQL database, and you ran Lambda up against that, you can quickly exhaust the thread pool on the database because of the number of requests coming in. So there's some shims out there that AWS has built specifically for the database stuff. But it's worth knowing that those drawbacks exist. So you kind of have to be careful, but it's still a really good place to get things off the ground and get things moving. Like, for example, I know that I think that A Cloud Guru, their website got things running and they ran for free for a good while because most of their stuff was done in Lambda. And we're making money well before they had to start paying for their AWS bill, which is kind of interesting. So going back to what we were doing, there's a lot of manual wiring there. That's great. But how do I get that up and running quickly? Okay, so that's where we queue the serverless application framework. And I can get this whole everything with the API gateway and the Hello World API up and running and deployed to AWS fairly quickly if I use this framework, which is out here at serverless.com. It's really convenient for writing these Lambda functions, and whether you're doing event level processing or whether you're doing HTTP requests or whatever. So it's an open source project in a CLI. That's basically your configuration and provisioning tool. They also have a paid for service that does some other stuff, maybe some CI/CD stuff that I don't know. I haven't bought into that yet. So I'm still just using their open source project in CLI, and it's great stuff. And you can kind of think about it like you think about CloudFormation, in the sense that it's like a configuration file that's going to lay out a bunch of AWS resources for you. But it's specifically tailored around the code base for Lambda functions. Okay. So if I were to take this guy, okay, and throw this YAML file into a GitHub repository or into a directory right next to this Python code and run serverless deploy, it'd roll out everything that we see here, which is pretty cool, because that's not much code to get all the configuration for the Lambda and the API gateway and all that sort of stuff laid up. And so that's super, super, super nice. So if we wanted to actually see this work, I've actually got it over here in a project, which is the project that you guys have seen. Serverless example, and it's got directions on how to do this. Okay. And I've got the serverless YAML here, and it's got a little bit more to it here than what I have on the slide, because I've done some interesting things and I've put some comments in here about why I'm doing these things. But if we wanted to actually go back and look at what's going on with the deploy here, I lay this guy into the project and I run SLS deploy, and what do I get? I get a CloudFormation template that spins up a bunch of resources that look like this, okay? And if you want to go look at this CloudFormation template, we can. It's over here. And it's got an API gateway on it. It's got a API method post. It's got an API REST API or API gateway REST API. It's got a hello Lambda function. It's got the API gateway permission. It's got a Lambda version on it, so that I can release multiple versions of the Lambda as we move the code forward. So why have I made changes to let me go back to where I was over here. Why have I made changes to this guy? What changes have I made? So the hello world Python example, if you were to go out to serverless, has a bunch of examples. Right? If I go to serverless examples and I go to AWS Python hello world API, there it is. And look at this. This is pretty much the same thing. Okay. And that pretty much does what I was explaining. Now, what changes have I made? Right? And why have I made those changes? Let's talk about some of the curiosities and nuances of the serverless framework here. If I were to deploy that, it'll spin up a, well, let's just try it. Let's just try it. Why not? Why not just make a directory? Right? CD serverless example, VI Lambda function, .py, and our code looks like this. VI serverless and their example. I'm gonna keep moving this black bar around for the you guys can't see the black bar. It's the Zoom black bar. Keep moving that guy around. Oh, I got to do that. I got to change this. So our handler here, escape. Lambda function. CTIO lambda function dot lambda handler. And we're doing a post. And I should be able to just go SLS or serverless. Doesn't matter which one you write if you've got the node module installed. Serverless is a node module under the hood. And so you have to install node, you have to install, and then you do an npm install -g serverless. Okay. And so this should, so I also have AWS credentials here under the hood. Okay. So that's what I'm doing here to get started. So if you guys wanted to actually see that happen, does that make sense to everybody?
Hey, I got a question for you.
Yeah.
What is the serverless? What is that service doing for you, rather than like you're using AWS on the back end?
Right.
You're going through serverless though. So what is serverless
So
doing?
what is this thing? What is this doing under the hood? Why
Yeah.
did I write this serverless YAML?
You install serverless,
Right.
So what is it?
What is it doing? That's a great question. That's a great question. We'll look at that. So it says it's doing all this stuff. What is it actually doing? So serverless is a node module that creates a CloudFormation template for you. Okay, that's all it is a CloudFormation template generator. And so what CloudFormation template did it generate? It created this AWS Python REST API dev update in progress. And what resources are on this guy? So under the hood, by default, it creates a bucket. It drops the code into that bucket. It creates an IAM role for the Lambda to execute under. It creates a log group for the Lambda function. It creates the API gateway. It creates all of these different resources for me that I would probably want if I were creating a standard AWS Lambda with an API gateway on top of it. But under the hood, all that's really happening is this thing is building up a CloudFormation template. So if we wanted to actually look at what's going on here, we can go and look in my directory. And I've got this .serverless directory, okay? And we can cd into that. And we can see this stuff, okay? There's this serverless state JSON. I'm not real sure what's in there, but effectively, this is the zip file that one would upload to their Lambda function as their code, okay? Does that make sense?
Yep.
Okay. And then it creates this create stack and update stack. So it's got two CloudFormation templates. The first one creates an S3 bucket to which the code gets uploaded. So effectively, it's saying, I want to make sure I've got a place for the code to land before I try to deploy the Lambda function. So it sends out a CloudFormation template that creates my bucket, waits for that to happen. Then it takes the actual zip file here. It uploads that to the bucket. And then after that happens, it runs a CloudFormation update that sends out a new Lambda function. And I think the create stack probably has an IAM role on it too. So let's look at those.
And it has to deploy it to AWS. It can't do it to Azure.
It can do it to Azure. That's the thing. That's the nice thing about serverless. We're just looking at one of the providers that accommodates. It has multiple providers, and I'm just an AWS guy, okay? But the serverless framework, if we were to go over and look at that, and we look at the providers here, you can go to Azure and be like, okay, what does my Azure CLI reference look like? What is let's see here, examples. Does it have a serverless YAML for Azure? So if you run this guy, it'll create you a sample Azure app, and let's see what that actually looks like. It probably would look like, let's say a node simple HTTP endpoint. So you've got your handler and you've got your context and your request, and this is like I guess an Azure function, right? I'm not that familiar with Azure, but I'm assuming that they've got something analogous to Lambda. You know what I'm saying?
Yeah, they do. Yeah.
Yeah. And so let's, I went too far. And they've got a serverless YAML here. And so the provider here is using Azure instead of AWS. If we went over and we went back and looked at my provider, right? The one that I was using. I was in the Python one.
Okay, yeah.
The provider's AWS, right? And so assuming you've got your Azure credentials on your CLI appropriately, right?
Mhm.
It sets sets up an Azure function with your handler being that file, right? Handler.js. And the method that's going to get called is hello, which is the hello function in here. And I'm less familiar, like I said, I'm less familiar with the actual context of what comes in, but you do the same sort of thing where I run serverless deploy, and assuming that my credentials are Azure credentials, it'll do the exact same thing, just in Azure. I don't know what the Azure analog of CloudFormation is. Maybe they do resource creation. And so the question then becomes, okay, where does the state get saved? Like, because we're doing a CloudFormation thing here. So that would be interesting. Let's see what happens. Let's try that. I'm going to do let's grab that serverless. This is the Azure one. Let me just grab the provider and see what happens. Okay, let's remove the .serverless directory. VI, the serverless YAML.
You have a Azure account, right?
I'm going to do something different.
Okay.
I hope that this runtime work. Well, let's see what happens. I'm going to do a serverless package. Unrecognized provider Azure. Did I spell that wrong?
Is it looking for?
Oh, okay. Plugin. I need that plugin.
Okay. Okay.
Okay. So each one of these plugins is a node, an NPM package. So I need to NPM install serverless Azure functions. So if I were to go NPM and then run the above, we'll see what happens. Originally, serverless was built around AWS. But I would think that we would get some sort of analog of, we should get the serverless directory, right? So let's go to the SLS package and see what happens. Did I spell that wrong?
Might have to look up the provider name.
Just copy and paste that whole thing in, right? You're relying on a provider plugin. Oh, I didn't put the plugin in. That's the problem. I need to do that too. Here we go. Oh. Well, that kind of gives you a direction for what to do there. I would think that, so does Azure have something like CloudFormation that accommodates for multiple resource declarations?
Yeah. Yeah. So,
File?
yep. It has the Yeah, I'm trying to think of the name right now.
No, that's all good. It's all good. So I'm assuming that it would build out something analogous to that, and then would upload
Right.
the file in a similar fashion to the way we're uploading it to S3 and would deploy it out there.
Yeah.
It would be interesting to see what that plugin has and how that works. And that's all, you know, part of the thing is their plugins for all these sorts of different things. And I was actually going to get into some of that down the line here in our plugins section. So I'll get to that further down there. Like I'll go over the plugins further down, but let me get back to continuing with this. Does that work?
Yep. Thanks. Yep.
Yeah, no worries, man. Thanks for the question. It was a really good one. So we saw the CloudFormation deployment happen, right? And if we were to look at the CloudFormation deployment and go out to API Gateway and click on that, it looks relatively analogous to the one that we had. It's got that Lambda Proxy integration. And this is the dev AWS Python REST API. This is the one we just created, right? So we just created this guy. And the stages, it's got a different stage name on it. I think that's okay. But if I were to copy this link address and paste this in and curl it, let's just right, change the link to the one we just deployed. We get a 502. That's awesome. Probably because it's a get, not a post. Did I do that wrong? I don't know what I did wrong. That's awesome. Anyway, it should work. The maybe the dashboard will tell me I got a 502.
The key needs to be body.
That's the right answer. Maybe. I don't know. Let's see. What does it say? What does it say? Where did the connection not happen? So we can go over and actually debug this. It's kind of fun.
You managed to crash AWS there.
Of course. That's just all part of the fun. The one that's actually written in the code base, by the way, does work. This is me just doing things just off the cuff for what that's worth. Monitor, do I have any invocations of this? Apparently it didn't tie it together properly. Did I call it? Copy. Let me just write it all the way out. Well, let's go over and look at the one that I actually deployed out of my repository. That's this CloudFormation template. And this one actually does work. So the resources on this has an API gateway, and I can call into this just fine. I get that back. I'm betting that something in my serverless config was wrong, and we don't have version control to look it back over because I was kind of doing that on the fly. So let's not worry about that example. So let's look at some of the things that I've done that differ from their example, okay? Their example gave me a bucket, a log group, and the Lambda function and an IAM role. I've found that I have a whole lot of these Lambda functions that I'm deploying, and I really don't like making buckets every time I deploy a Lambda function, right? A new bucket for every Lambda function. And so I've decided, okay, I'm going to go and create my bucket separately. I want to put all of my serverless configurations into one bucket. So that's why I went in my project and specifically declared a deployment bucket. And this is a bucket that I've already created. And so all of my Lambda, all of my serverless deployments will go into a single bucket as opposed to each deployment creating its own bucket, which is kind of a good practice for what that's worth. Okay. I've got this disabled logs here. The Lambda by default will create you a log group anytime it stands up a Lambda function. I'm not really sure why serverless in their code base creates the log group in the CloudFormation template. And I've actually run into issues with that in the past where I've wanted to delete the everything except for the log group, because I don't like deleting log groups, because deleting log groups is actually a bad practice in AWS, because keeping logs is a good idea. And at one of my places, they were like, you can't delete the log groups. We don't want you to delete the log groups at all. So disabling logs here means that I don't want the CloudFormation template to have a log group in it. But under the hood, Lambda will create one for me anyway, so the log group exists. So that's what my comment here specifically says. Oddly enough, if you disable logs, then the IAM role doesn't work. The IAM role creation doesn't work anymore. And so you have to create your own IAM role. So this is also a good practice, is to create your own IAM roles outside of the stuff that you're provisioning with your infrastructure. And so you can declare your own role and pass that in. And so these are some of the configuration options that you're afforded in your serverless YAML. The actual, hold on. If you actually go out and look at the serverless YAML schema, there are a ton of different configuration options here that are afforded you, which is really, really nice. But it's also nice to have the super simple, be able to get out and go running. You know what I'm saying? So that's kind of the example that I've got. My example also has, for what it's worth, I don't write things without unit tests. So I put unit tests in, and you can actually look at what the payload looks like coming in. This is the actual payload that would come from the API gateway. And you can look at what the generated CloudFormation template looks like. So this is actually what gets generated and deployed as your CloudFormation template. If you wanted to actually read through what that fully looks like line for line. So I kind of just put that in there as a reference point, because it's kind of nice to see what all gets spit out by the serverless framework. What else do I have? I've got a make file that does everything for me, because it's just nice to have that. So that's my example project. What else can we get from serverless? We've kind of gone over some of this deployment to various cloud providers. I think that I haven't done it, but doing a deployment using it to the Google Cloud Functions would be kind of fun, and doing something to probably Knative would be kind of fun. I think those are kind of next on my list for things that I need to tackle. Another point is you can declare all the portions of your CloudFormation template under the resources section in their serverless YAML. So if you wanted to declare a Dynamo database, you can declare that. If you wanted to stand up a Aurora instance, you could declare that in your serverless YAML so that you could have a relatively complete application from your serverless YAML. Whether or not that's a good idea, I'll leave that up to you guys to decide based on, you know, the design decisions at your place of work. Where I currently work, we kind of like to do things in mono repos. Some people like that, some people don't. Serverless affords you the option of being able to deploy a collection of Lambda functions all out of one serverless YAML, which is kind of fun. So you can kind of do the mono repo thing if you want to, or you can do individual repos and have each repository have its own Lambda function and its own application. So that's kind of a nice thing. And the plugins section of the serverless YAML allows you all of the serverless plugins that exist out there. Okay. And there are a ton of serverless plugins out there. So if I were to go look, we've got this directory of serverless plugins, and we can actually go through and find all these different plugins out here that do all sorts of different things for me, which are super sweet. Each one of these guys is a NPM package, and you install them the same way. Because you're running NPM already, I don't know if you guys want to run your Lambda functions as JavaScript or TypeScript, that's totally good to go. The serverless guys would probably support you on that because they've written their stuff in JavaScript, obviously. So what are some cool plugins? The serverless offline plugins are a really nice one that allows you to do offline development of Lambda functions so that you can actually run the Lambda function locally on your machine. It's really nice to be able to do that and stand up that Docker container and run it locally and have all that stuff work. If you're going to do the TypeScript thing, serverless Webpack accommodates for that. That's what I use a ton at work. A lot of our stuff is TypeScript. And so I found that to be a super popular serverless plugin. And another one that's good to know about is the serverless plugin warmup. So that effectively is a plugin that does the keep warm thing on your Lambda so that you don't have that cool start or that cold start that we talked about a while ago. It'll under the hood make calls to your Lambda function every so often so that even if you're taking a request every 30 minutes, the Lambda is warm and doesn't have that 500 millisecond overhead. So that's a good one to know about. And if you wanted to look at the most popular ones, they're out there on this blog. So that's what I've got. Do you guys have any questions? I'm glad that you guys threw me questions as I was going along. Those were kind of fun.
You mentioned that the serverless can have a file system earlier on. Can it also attach to a database?
Yeah, so if you wanted to actually have an example of a Lambda function attached to a database. Let me see here.
Or a key vault, maybe. Yeah.
Sure. I actually, if we look at my Lambda functions, I've got my Lambda function for my Alexa app actually running against DynamoDB, okay? And so in here, I've got a DynamoDB table, and it actually is doing puts to the DynamoDB table based upon, let me see here. So I'm using Bodo to grab the DynamoDB client and doing puts to the DynamoDB table directly from the Lambda function. And so if I were to go over to DynamoDB, which is a NoSQL database that is an Amazon NoSQL database, you can see all this stuff in here in the DynamoDB written from the Lambda function. You can do SQL or relational database stuff from Lambda. It's a good idea to use the, if I recall correctly, it's the it's this Lambda Aurora plugin that does a thread pooling thing for you so that you don't blow out the thread pool on your database, if that makes sense. You know what I'm saying? So let me Google that real quick.
I just want to know if it could, it sounds like it can do it, so.
Oh yeah, totally. I mean, any web request off the back you can make. And if you're making them inside of AWS, it's even cheaper, right? Because if you stay inside your VPC, it's inexpensive. Other questions?
Let somebody else go.
Not a question, but a comment. Like, I think when you like kind of chain together stuff in Lambda, like say their database connection, or like doing some kind of data processing or writing and reading from files, whatever. I think the thing we have to be a little bit careful about a couple of things. First, the memory, right? Like, so you want to see that your function has enough memory to do what it needs to do. So if you're buffering stuff out, you want to probably have a buffer to read and do any input output kind of stuff and control that buffer. And with database connections, you want to be careful about the timeouts, right? So you don't want to run out, because your AWS will cut off the function when it hits the timeout. So
Right.
so that those are some things to think about. So you wouldn't typically try to have full-fledged APIs, like say you would write on a Express server or a Java EE server. But yeah, those are some things to think about when you try to design the API, design your functions.
Yeah, there are definitely some interesting pitfalls and drawbacks that you can run into, but you can still do a whole lot with it, which is really cool.
Is it creating a public IP for you, or is it?
Under the hood, the NAT gateway that you will end up getting an IP address assigned, but it might be an IP address of a host of machines because it's a NAT gateway. So when I am going out of like if I were to create a VPC here, let me see, do I have a VPC created? Let me look. I've got several VPCs. So route tables. This is, what are the routes on this? That's got an internet gateway. Routes. Do I have any of these with a NAT gateway? Internet gateway. So you'll invariably end up with the IP address of the internet gateway going out, if that makes any sense. So you're not really guaranteed what your outbound IP address is going to be, and it's generally the last resource in the chain of network things, but you're not actually getting an IP address as in like you don't get a machine that you can get into for what that's worth.
Right.
It's all just, I get the runtime for a short amount of time for when the code runs. So I get whatever the runtime was, and I get my output. So just make sure you're logging things appropriately, because you do get your standard out, which is nice. But it's Amazon's IP fundamentally under the hood. Other questions?
Use case. You familiar with HashiCorp Vault?
Sure.
So that's a lightweight binary, you know. Could that just go on a serverless? Access it by API only. I have a key vault in the back end.
So if I were to try to do that, I don't know. I think I'd have to stand up HashiCorp Vault on an EC2 instance. I don't think I could run that through a Lambda function, because I don't get control over the runtime that the Lambda function has under the hood. I only get control of what's inside that function call, if that makes sense. So like in my Lambda function here, I only have control over the stuff that's in a zip file in some Docker container somewhere. Now, you might be able to hack the serverless runtime and get down onto the file system, but the general guiding principles for what they're going for is they don't want you to have to think about the file system under the hood and think about what binaries there are under the hood. You just know that you have a language's runtime and that your function call is going to get executed.
Gotcha.
Some of the time, though, you do have to bring along your dependencies. So there's some curiosities in that regard. But aside from bringing along your dependencies, you're not supposed to know about much else for what that's worth.
All right, cool, thanks.
Yeah. Any other questions? Can you hear my daughter singing in the other room?
No, not really. No.
Okay, well, that's good.
Yeah, I don't see any questions in the chat. Right. And does anyone have any more questions?
Cool.
Yeah, the one question I kind of have, and you briefly touched upon it.
Yeah.
But like, I was wondering around the tooling. So for example, you mentioned the S3 buckets. Like, you don't want to create a separate S3 bucket every time for each function that you're deploying. Similarly, I'm sure there are like maybe like the API gateway and things like that. Like there are different components, so you want to reuse the components. So just serverless framework, is it smart enough to know that, hey, I already created a gateway, so I don't have to create a new one. I already created a.
You have to be careful about the way you use it. So you can get yourself into some pitfalls in that regard. It likes to create more resources for you than you maybe want. So if we go back and look through the CloudFormation templates that I stood up here, we see that I got a new API gateway between this one and this one. So if I was going to try to have everything live on the same API gateway, maybe I would want to think about putting all of those functions into the same serverless YAML file and build it that way. There are, I mean, if you guys have more questions in that regard, I can go out and try to answer them and get back with you on like the best practices in that regard. But I'd have to do a little bit more trial and error on figuring out how to make sure that all of the resources get laid out properly for a collection of APIs under one, or a collection of resources under one API gateway, if that makes sense.
Yeah. I think because I mean, yeah, for a personal hobby or whatever, I think, it doesn't matter. But when you're deploying in an organization or for a company or a business, then you want to reuse and like control resources as much as possible. Even the roles and stuff, right? Like the IAM roles.
Right.
You may just want to use, and it looks like it allows you to pass in certain roles, etc. So.
Right. Right.
Another thing to think about as we build upon this framework. So
yeah, for sure. Interestingly, I'm working through some of those best practices at my current job, because a lot of the guys there have kind of taken this thing and gone running with it, and I'm like, oh, whoa, let's reel it back in a little bit, guys. Let's reel it back in a little bit so that we've got a little bit more standardized practice on things. So yeah, I'm actively working through some of those interesting pitfalls. I'll keep you posted as as it unfolds.
yeah, and you mentioned a Cloud Guru before the earlier in the talk, and yeah, I think they had at one point, I don't know if it is still true, but at one point, not almost everything they had was on AWS, and most of it was serverless.
Right.
They had almost not, and but I'm like, but that something like that, like, is so massive to manage without tooling and without like controls to make sure things are not running away out of, so the cost picture is nice, but only as long as you're not recreating a lot of duplicate resources.
That, and you got to make really careful design decisions to have everything work appropriately, right?
Mm-hmm.
Because you've got to be careful about whether or not you're using a relational database or how you structure your data, because it's forcing you to kind of use DynamoDB as opposed to using MySQL or something like that. And so you just got to be really careful about how you make your design decisions so that everything lands correctly. But if you do it that way, then you can win big because it's really inexpensive.
Yeah, definitely.